All right, welcome everybody for installment number 3 of this little project here that we have of Stephen Chilton Architects for the British Expo Pavilion. And here we've come to our, and with Michael. Hello, Michael.
Hello. Hi,
Hello.
everyone.
So again, this is kind of a show and tell introduction to a workshop we're going to do later on. So if you're interested, register below, express your interest, and we'll let you know when that happens. The idea here is that this original pitch, which came second, by the way, was done using 3ds Max and V-Ray, and especially the animation of all these little umbrellas, as Steve calls them. From my discussion with him, was very, very difficult to achieve and to control using 3ds Max and with the additional render time and so on. So this is the challenge that we took on with Michael to see how we could leverage the power of Unreal, and in this case, very specifically of vertex animation. So this animation is not done in keyframe or as we would normally be doing it or thinking of it, but it's using the material. So this is what Michael is going to show us because he implemented that on his side. So I'll hand it over to you, Michael. So if you can share your screen and
Of course, absolutely.
you'll walk us through the material.
Let's try that. Can you
So
see
I'll
my
stop
screen?
sharing my screen, and you've started sharing your screen. Okay, here we are.
Can you see that? Okay.
Yep.
So we have one of the umbrellas here. So this is what I remodeled in Blender. That's just what I'm familiar with personally. And what I did to enable the control of the vertex animation was to do some vertex painting on the vertices itself. So here you can see that in the center, the vertices are all black, value of 0 ultimately. And on the outer vertices, we have a value of 1 or white. So that was a little prerequisite. And it's a bit of prep on the mesh so that when we look at the vertex material, we're bringing in elements like that, vertex colors, to control which vertices we want to have the animation applied to. I'll explain all of that in a second. So, looking at an overview, what we have here and what the challenge really enabled us to do was look at a few different Unreal technologies working in concert to make this work and to make it perform. So we have the mesh, as I've shown you, with the vertex colors. We have the use of a blueprint with an instant static mesh. And we have the texture control in terms of the animation itself. So let me just get my...
Sorry, I'll plug our last video, which is where we covered the instant static mesh. I'll put the little nifty little link.
Excellent. So for those who are familiar with materials, we have our material attributes node at the end, which we start plugging different nodes into. So if I look at yeah, umbrellas themselves, as that I'm simply creating alert between two colors. But this per instance random node is something that can only be used with a blueprint that has an instant static mesh component. It also works for landscapes because that is the same mechanic. It works by using instant static mesh, which is a much more performant way of re-rendering the same geometry in different transforms. So a different location, different rotation, and different scale. So the per instance random node here ultimately is just a random number between 0 and 1. And what that is then doing is it's feeding into this material on a per instance basis and saying, okay, for this umbrella, the value is 0. For this umbrella, the value is 1.3, sorry, 0.3, et cetera, et cetera. And with our mesh here, it's doing that 5,800 times, just give us slightly different shades between these two colors. So that's basically
That's
what's
the color
controlling variation.
variation.
That's color variation being fed into the base color and the emissive. And what I've added here is just a multiply and a boost with the scalar parameter, which enables me to increase the emissive value of that color.
So that's what's giving out the light in the scene that I mentioned in the first video.
Exactly. So we're using emissives rather than lights themselves. And emissives now with Lumen can affect the scene lighting. So it's incredibly powerful and kind of visually very appealing. So that's dealing with the color. Now, the world position offset itself is handling the animation. And if I give you a quick overview, we've broken down the animation into two areas ultimately. We have the animation itself of the value that's driving the umbrella's opening and closing and rotating slightly. That's all being handled through the use of a texture. And here, what I've done is to create some variation is I'm looking at the texture, but I'm actually masking it into the three axes of X, Y, X, Z, and Y, Z, so that the animation in combination, and I'll show you this in the material instance in a moment, the animation in combination just gives it a more fluid feel rather than the animation just happening in one direction. So when we go into the workshop, we will rebuild this and I'll show you how each of these elements is working individually, but then also how we can then add in some weights to be able to control it and art direct it in a much more subtle way. So this animation is being driven by a texture. And as I say, I'll show you that in the material instance shortly. Now, in terms of the vertex animation, what we're doing is we are, if you recall, working with the vertices of the mesh itself. So those outer vertices have a value of 1, and the inner vertices have a value of 0 based on that vertex painting and the vertex color of each of those vertices. So that texture value is being brought in and being clamped so that it gives me some control over how much I want the outer vertices of that umbrella to expand out and back to the center. So these scalar parameters give me that control. And again, I'll demonstrate that. There's some interesting concepts to conceive around how you work with a mesh in local space, world space. And now that we are using, again, a blueprint instant static mesh, we have to convert the transforms of each of the mesh to what's known as instance and particle space. Again, it's just understanding that we have these different spaces to work in. When we build up this vertex shader from the beginning, I'll explain each of those concepts in turn and demonstrate what happens when you might be getting unexpected results because of the way that the vertex information is being interpreted across these spaces. I'll make sure I break that down into
yeah, so that's the point, isn't it? The absolute world position and the transform position, that was a kind of a crux to a nut to crack, something to really understand that the original shape comes into world position, and in order to apply a transformation to it, we need to convert that space, if you want, into a local space.
Yeah, and then again, now that it's in the blueprint instant static mesh, we have to change it into this other option, which is the instance one, because the transform is actually relative to the pivot point of the actor that it's part of.
Mm,
So
mm,
again, I'll break that down so that we start in local space, we then move into world space, and then we move the shader into instant space. And you'll see that very quickly it can feel quite confusing because the results aren't what you were expecting, but the reason the results aren't what you're expecting is because you're working in the wrong space. But
yeah.
I'll make sure that we can kind of step through that and show examples of what works and what doesn't. But ultimately, what we're doing here on a per vertex basis, again, just using a lerp to kind of define the open and closed state, is that for each vertex, we're taking the absolute world position and lerping that position back to the object pivot point, which is at the center of the geometry of that mesh. So using this lerp, each vertices, and then using that value from the texture is as the alpha is moving from its original state back to the pivot point. And that is what's driving the animation of the vertices moving in and out. Now, the next cluster of nodes is actually masking that and saying, using the R and G, which is the same as X and Y in vector space. So with vectors, you can have a vector that is red, green, and blue. And this is where sometimes within a material, we can switch between those three references, but they correlate also to X, Y, and Z in a reference. So here, where I'm masking R and G, I'm actually masking X and Y. And the reason I'm doing that is because I don't want the absolute world position, when it's lerped back to the pivot point, I don't want it to affect the Z coordinate at all.
Mm-hmm.
I just want the X and Y points to come into the middle. If I don't mask it, can you see me on screen?
Yeah.
So if I don't mask it, all those points will go into the middle. So it will have a vanishing point because we're masking everything back to that.
So here, yeah, we're not scaling in Z. Okay, that's fairly straightforward.
We're not scaling in Z. We're just scaling in X and Y. And that's what this, which is known as a component mask, does. And all I'm doing is I'm putting that back into a float 3 so that this value of Z is constant. Nothing changes when this value is driven. I'm overwriting it basically and keeping it at 1. So because our actor might not be at the world origin, we have to then re-offset our pivot point so that our animations work relative to the position mesh in the world. So that's just what this cluster does. I'm just subtracting the pivot point back from the transform, which means that I'm effectively setting the origin of the mesh in world space locally to 0, 0, 0, so that any of the animations are relative to its position in world space. So that's just a kind of corrective measure. And again, I'll demonstrate that and why we do that.
Okay, and we're back to the beginning. Okay.
So this is one animation, not quite. So this is the animation that deals with the vertices moving in on the X and Y. And because we're in instant space, that can happen at any transform and any rotation, because we're converting those transforms. But then what we're doing here, I've also added in. So when you have vertex animation, you use an add node to start layering different transforms on top of one another. And what's happening here is we've got a cheap rotation around the axes. So the umbrellas actually slightly rotate as they're shrinking to reflect the kind of origami nature of the umbrellas in the way that they work kind of mechanically. And that value is a rotation value that we can control here in this scaler. I've actually locked it off from a scaler because I found out what value I wanted to use, because from a kind of artist point of view, I didn't want to give control over that rotation. I can plug that back in, and let's do that. And I can show you what impact that has. But because I found the sweet spot, I just thought, let's just leave it rather than have it as a scalar value. But I'll demonstrate that in a second. So we are just rotating around the z-axis. So this is what we're using this cheap rotate around world axis for. And in a similar vein, we've got the pivot point. So we know the pivot point of the object because we use the object pivot point. And we have the world position for each of the vertices. So again, we use that world position. And and because we're just rotating around the z-axis, this value, which now says 1.0, let me put that to a default value of 1.55, which is my sweet spot. So it works as expected. Ultimately, this value determines the amount of rotation around the z-axis, and we're adding that on top of the scaling animation.
Okay, great.
And similarly to what we've done here, we're just making sure that that offset rotation is repositioned again by using exactly the same technique of subtracting the pivot point to the transform position. And
great.
The very last, very last point is those inner vertices that I made black, I didn't want that animation to affect any of those vertices in the middle. I wanted those to remain locked. And the reason they're painted black is because we take that vertex color information on a per vertex basis. Knowing that it's black, I multiply the animation by that vertex color, which basically cancels out everything. Because as we know, any values multiplied by 0 are 0.
Yeah, so that's where the vertex color comes in.
So the vertex color comes in and controls that animation. And that's ultimately what is driving
this animation. So, I mean, I'm sure, like most people watching, it's kind of completely going over my head because, well, that's the nature of these kind of complicated network nodes. But it's really useful to be able to see what how that's built, and again, like I keep saying all the time when I show this to people, is that don't worry, don't get overwhelmed by the complexity of these things when we walk through them this way, because this is not how it happens. We don't sort of miraculously sort of plonk the just make them out of our heads like that instantly. It's just a slow process of trial and error, and we're building them and start, like Michael was saying, just add a single node and then build it and build it and build it, and that's how they get massive in the end. This is more sort of showing the history, and then obviously afterwards it's optimized and everything. So
the thing I'd add would be to say that it's really understanding that these techniques Unreal has the capability of handling these techniques, and it's these techniques that make things super performant and really enable this complexity. But the vertex animation pipeline is really exciting, and it seems overwhelming, but again, when we break this down, everything will click, because it's super logical, and it's just sort of being aware of what space you're working in when and how you can convert things
exactly
back.
Yeah,
it's so much fun. It really is.
Yeah, and exactly, and again, what we're going to do in the workshop is we're not necessarily going to work on that example exactly. We'll break it down, the principles, and just work on really simple blocks that you'd be able to work on your own things and apply, and maybe kind of on a much simpler and less sort of grandiose example to start with.
Definitely. We can get to that point, easily. And I think it's just understanding those 3 or 4 steps to get to that point.
Yeah, exactly.
How liberating that is creatively once you've got that as a competency.
Right, and that's the in closing remarks, that's really the idea, is to leverage this huge power that we have to enhance the visuals, and to really use this real-time technology, not just for the rendering like most of us will have done to make pretty pictures and kind of walk around like you would do in a game, but to really begin to leverage the interactivity and the animation and power, because obviously to animate these 5,000 umbrellas in any other software that I've worked with would be a bit problematic, to say the least. Cool. All right. Well, we won't keep you much longer. Thank you very much, Michael, for this. And
welcome as ever. I love the challenge.
yeah,
So,
great. It's cool. And we'll see you all next time. Bye.